constant rate of change. This is also known as slope. When you guys get into 8th grade next year, whether you're going into pre-algebra or into the Algebra 1 class, they're going to be talking about slope, which is the idea of a constant rate of change. It's how your value changes from y to y over the change of x to x. And when we talk about a constant rate of change or a slope, we're talking about what's considered to be a linear function. So if I say the word linear, what do you think of? What word comes to mind?
Line.
A line. Okay, linear. Linear is the idea of a line, and a line is a straight pathway. So when we're talking about a constant rate of change, we're talking about something that is linear, meaning it has to be straight. If it's not straight, we don't have a constant rate of change or a consistent constant rate of change or a slope. We can estimate a slope by giving an estimated linear function to it, but that's the best that we could do. Linear functions are going to be the only ones that have slope. Now, not all linear functions are proportional. So we talked about proportionality prior to our test, where if it's proportional, it has a consistent unit rate throughout the whole entire problem, meaning the y divided by the x was consistent throughout the problem. Not every linear function is proportional, but every linear function has a constant rate of change. Okay? So let's go ahead and all we're going to do is show examples of linear functions in table format. And then we'll go on to the slope video and talk about the different types of slope.
Excuse the interruption, Ms. French-Zheng. Can I please get Julian to the counseling suite, please?
Can I send him after notes are done?
Absolutely. Thank you so much.
Thank you. All right, so we're going to be talking about time, how time changes versus the money that's going to be earned. The change of time versus the change of money earned. So over the course of time, at 1 hour, we're earning $10. At 3 hours, we're earning $30. At 5 hours, we're earning $50. And at 7 hours, we're earning $70. Now, remember when we talked about how we set these tables up? These tables are set up in the system of x and y's. Your x is always on the left side, your y's is always on the right side. So I'm going to go ahead and above this I'm going to put an x for my label, and above money earned I'm going to put a y for that label. And now the concept of constant rate of change. And for the sake of saving space, I'm only going to write constant rate of change one time. I want you to, for now on, identify it as CRC. CRC, constant rate of change. So when I write down CRC, you need to know that I'm talking about a constant rate of change. CRC is represented as a fraction where you're taking the change that's occurring in your y's. So not a specific y value, but the change that goes from one y to the next, over the change for your x's. And by change, I mean how much are we increasing or decreasing by from one point to the next point. Going from one point to the next, what is that increase or decrease moving by? So let's talk about the y's, the change of our y. I'm starting at 10, and then I move to 30. So to go from 10 to 30, I'm going to note that this is an increase. So I'm going to go ahead and put a plus sign. We're increasing. How much are we increasing by? 20. We're increasing by 20. To go from 10 to 30, that's an increase of 20. What about when we go from 30 to 50? What are we increasing by? 20. And from 50 to 70, what are we increasing by? 20. Okay, so when I talk about my change of y, I'm talking about the value 20, a positive 20. So I'm going to put a positive 20 up on the top. Now, for my x's, the change in my hours are also increasing each time. What am I increasing by each time? By 2, right? From 1 to 3, I'm increasing by 2 hours. To go from 3 to 5, I'm increasing by 2 hours. To go from 5 to 7, I'm increasing by 2 hours. So that means my change of x is an increase of 2. So now I need to identify what my constant rate of change is. So I always simplify this fraction. What is 20 over 2 going to simplify to? 10 over 1. So there's my answer. My constant rate of change is 10 over 1. Now, it just so happens to be that my constant rate of change also happens to be my rate of proportionality. That's because this is a proportional relationship. And in proportional relationships, your proportionality and your rate of change are always going to be identical. If it's not a proportional relationship, then you will not see a connection between a y and an x versus the change of the y and the change of the x. They will not be the same. Speaking of which, let's take a look at a problem that does showcase that, where it's a non-proportional relationship. But again, non-proportional relationships still can have a constant rate of change as long as it's a linear function. Okay, so if we have the cost of one ticket, the cost of one ticket is going to be $20. The cost of 4 tickets is $65. The cost of 7 tickets is $110. The cost of 10 tickets is $155. So I want to know what is the constant rate of change. Now again, the rate of change is not the same thing as proportionality. In the previous problem, 10 divided by 1 is 10. 30 divided by 3 is also 10. 50 divided by 5 is also 10. 70 divided by 7 is also 10. It happens to be that the proportionality is the same thing as your rate of change. It won't work in this problem. 20 divided by 1 is 20. 65 divided by 4 is not 20. So you have a different rate of change. You have a different rate of change, or a different concept of proportionality, because there is no proportionality here. So you cannot just take a y and divide it by an x. There is a difference. There is a difference there. You have to set it up where you find the change that's occurring from one value to the next, and find the change that's occurring from one value to the next on your x's, and then divide that. So let's go ahead and set this up. Again, tickets are going to be your x value. Cost is going to be your y value. Our constant rate of change, our CRC, is going to be set up as the change of the y over the change of the x. Change of the y over the change of the x. So when we're going from 20 to 65, that is an increase. What is it increasing by? 45. When we're going from 65 to 110, it's an increase of 45. To go from 110 to 155, it's an increase of 45. So the change in our y is a positive 45. Now for the change in our x. We're going from 1 to 4. We're increasing by 3. 4 to 7, increasing by 3. 7 to 10, increasing by 3. So we have positive 45 over positive 3. What does that simplify down to? What's 45 divided by 3? 15 over 1. So our constant rate of change is 15 over 1. That means that the tickets each cost $15. You probably had a processing fee that was an extra $5 on top of it. Okay? So again, the proportionality is not there. There is no proportionality, but there is still a constant rate of change. Let's do one more example. You have X number of trees, you have Y number of apples. X number of trees and Y number of apples. Again, the constant rate of change. You have to put the change of Y on top. You have to put the change of the Y on top. You have to put the change of X on the bottom. Who can raise their hand and tell me what is the change of Y? The change of Y that's occurring. Are you wanting to volunteer, EJ? What's the change of our Y? 100. Every time we're going from one set to the next, we're increasing by 100. Every single time we are increasing by 100. So our change of our Y is 100. Who can raise their hand and tell me the change of our X? Tony? 5. The change of our X is a change of 5. Every time we move from one data set to the next, we're increasing by a value of 5. So our change of our X is 5. Now all we have to do is simplify it. Braxton, what is 100 over 5 going to give us? 100 over 5, what is that going to equal? Psst, use the yellow thing in front of you. Huh? 20. It's going to come out to 20 over 1. Comes out to 20 over 1. Now, I'm going to go ahead and pause the notes video so that we can move into a quick little video on... So, like I said, it's a silly video, but it does stick with you. The concept of the idea is a familiar concept. Think about it, maybe not when you're skiing, but how many of you have ever gone riding your bike? Okay, riding a bike, if you're riding uphill, is that easy? No. When you're riding uphill, when you ride uphill, it's a little difficult. So you're kind of like puffing along, right? So that's what he was saying, puff, puff, positive. Okay, so puff, puff, positive. I'm going to just put puff, positive. Okay, because it's hard to get up the hill. But once you get up the hill, that's the easy part. You're up the hill, now all you have to do is go down the hill. So that's why he was saying it's a nice negative. Make sure you're copying this down on the next slide. It's a nice negative. All right, when you got to the flat surface, there's no adventure to it. There's no going uphill. There's no difficulty. There's no going downhill, something that's easy and fun. So this is why he said it's zero fun. It's zero fun, the idea of zero slope. So this is a positive slope, negative slope, zero fun. And then the last one, he says, is a curse word. The reason why he's saying it's a curse word, though, guys, is because in a calculator, how many times do you guys come up to me and going, I don't know what I did wrong, and it's popping up an error? Syntax error. When you have an undefined slope, it shows up as an error. That's why they call it the curse word of math. It's an undefined value. So I'm going to tilt this for just a second to write that down. Undefined. Undefined is a vertical drop. It's a straight vertical drop. That's called undefined. So very quickly, looking at it in graph form, so this is just a picture of a hill, right? But you guys need to know it as a graph. So as a graph, if I draw a coordinate grid, a positive slope starts at the bottom left and works its way to a top right. That's what a positive slope is going to look like. When we're talking about a negative slope is going to start at the top left and work its way down to the bottom right. That is a negative slope. Zero slope is when you just have a flat horizontal line. A flat horizontal line is called zero slope. That's called zero slope. A flat horizontal line, zero slope. Oh, I should have done that in blue. Sorry, guys. That should have been in blue. And then an undefined slope is a vertical up and down line. That's undefined. Undefined is a vertical line. Zero slope is that flat horizontal line. That's your zero slope. Okay? Now, what you're going to be doing today, you have a paper.